So what I was looking for on Sunday was like 1 through 14 from the book, and then worksheets 1, 2, and 3.
Yeah, but for like the new one, like it was chapter 3, 17 to 26.
Yeah, so if I looked at the last set of notes, 15 to 26, worksheet 4, just number 2, and then worksheet 5, numbers 5 and 7.
4, 2.
Yep, that's on the notes in the content library.
I was looking on mine already. Okay.
Oh, it might have been not totally updated or whatever, but I try to make sure it's in at least a couple of places. So if I mess one of them up or I forget, it happens. It's so hard. There's so many places, you know.
And then could you do number 24?
I told you only got one question. I'm just joking. You can handle number 24 from the problems.
Yes.
Sure. All right, it says identify the period for the function, then graph it on the interval from negative pi to 2 pi. Did you have any problems with the period?
No, I just really don't do the
Oh, that's the A. So the period is just going to be 2 pi, right? So I will set up my map. So I'm going from negative pi over 2, undefined, to negative pi over 4, negative 1, 0, 0, pi over 4, 1, and then pi over 2, undefined. So that's the points from my parent function. Again, I'm just getting that from the reference points list. So I'm going to plug that into cx plus h, ay plus k. C was 2, h was 0, a was negative 1/3, and then k was 0. So that's just my map. So 2 times negative pi over 2 is negative pi. Negative 1/3 times undefined is still just undefined. 2 times negative 1/4 is negative 1/2. Negative 1 times negative 1/3 is positive 1/3. 0 times 2 is 0, and 0 times negative 1/3 is 0. 2 times 1/4 is 1/2, and then 1 times negative 1/3 is negative 1/3. And then 2 times, or 1/2 is 1, and then undefined times whatever, still undefined. So it looks like I'm going to be going up by halves, half a pi's. Seems like it would make the most sense. So I'll draw my xy axis. So negative 2 pi, 1.5, 1 pi, negative pi, half pi, 0.
So like the negative pi undefined, that's like the
Correct. So start by drawing in my asymptote here. And I'll draw in my other asymptote over here. And then I have negative pi over 2 and positive 1/3, so maybe like right there. And then positive pi over 2 and 1/3 be like right there, and then 0, 0 is in the middle. This is just going to look like one of those guys. And then just kind of following the pattern, I have one of these coming in like that. And then over here I'll have like one of these coming in like that. Yeah, you have to draw the extra and extend it to fit the space. Yeah, you do. Of course. It didn't take but like 10 more seconds, you know? It's not that big of a deal. Is that okay, Sophia?
Yeah.
You sure?
Yeah.
Piece of cake? Okay, cool. Well, it looked like a piece of cake when I did it anyways, right?
How did you hear?
Again, I've been doing this for a long time. Like, wasn't that loud in the room? You don't talk that quiet. What can I say? I don't know. All right, now that everybody's good and embarrassed. Any other questions? I'm happy to do more if there's more questions, even if it's about things that we've already been checked. That's okay still. We all get to things at different times, right? Okay, fair enough. Last thing for chapter 3 that we want to talk about are these harmonic motion story problems. So, what kind of situation, like physical situation, would we need to describe using like a sinusoid equation? Yeah, like anything where you have an object that's spinning, right? So like if you have a gear that's spinning or like a Ferris wheel for something that we probably have a better frame of reference of like kind of understanding. But anytime you have like an object that's like rotating. So let's just run through a couple of examples. So here it says we have a 100-foot diameter Ferris wheel positioned where the center of the Ferris wheel is 55 feet off the ground. The Ferris wheel spins at a rate of 1 revolution per 2 minutes. We're asked to construct a function to model the height of a rider, where height is measured in feet and time in seconds. And the rider enters the Ferris wheel at its lowest position. Okay. So what we want is we want some function h of t. That's the height of the rider dependent on some time t. And as I intimated, since this is an obvious situation where that height is going to be changing over time, but there's only so many heights that rider can take, a sinusoid seems to be really an appropriate descriptor there. So just to give you a visual of what's going on, let's say that like this is our Ferris wheel. That's not a bad circle, Mr. Kulik. So like there's it on the ground or whatever. So this is going to be some kind of t comma h of t. And that height is going to be different depending on the time as the Ferris wheel rotates around, but those heights are going to repeat. Each time it goes around, it's going to pass the same heights again and again, because if you've ever been on a Ferris wheel, you're on there for a little while, you're spinning, you know what I mean? Everybody can kind of see how this is going to be a sinusoidal relationship, right? Okay. Sure. Right? Okay. So let's go ahead and start labeling some of the attributes here. It says that the diameter of this Ferris wheel is 100 feet. It says that it's 55 feet off the ground. It says it spins at 1 revolution per second. I'm going to write that down because that doesn't seem like a physical part to the picture, at least obviously, right? And then it says that the rider enters the Ferris wheel at its lowest point. So we have like some other ramp here that the person walks up to get onto the Ferris wheel. That's like right there. Everybody's okay with that? Rita? Oh, yeah, sorry. Thank you. Yep, that's just me not rereading what I had written down there. Yep, absolutely. Okay. So let's start thinking about what these values that we're given relate to our A, C, H, and K. Everybody cool with that plan? So I think this is the most obvious. What is the height off the ground relating to? What do you guys think? Should be K, right? Because all that's doing is taking all the heights on the Ferris wheel and shifting them up 55 feet, right? Whatever the heights would have been if it was like starting at lowest point at 0 versus 55 feet off the ground, all the heights are going to stay just shifted 55 feet, right? So you're right. That's going to be K. So if that's the case, what's the lowest height that our Ferris wheel can have? 55 feet. And the highest? 155, right? Up here is just some kind of t comma 155. So what is that diameter related to? Not the period, the amplitude, right? So the lowest we can go is 55, and the highest we can go is 155. What must the middle be? Yep, so what height is in the middle there, though? 105, right? And Mr. Kulik's already screwed this up, huh? The K isn't 55, is it? Mr. Kulik, you dum-dum. I made a mistake. So what's the K really here, guys? The 105. What do you mean, what? So if we think about this as a graph, let's think about it as a graph, right? If I think about it as a picture, we start here at 0, 10, or 0, 55, right? We know that's a minimum because that's the lowest part on the graph. And then sometime later over here, we can get up to a height of 155. Everybody agree with that? So the midline there has to be 105, right? Just like we had done before. That this is like, Y max is 155. And Y min is 55. So you guys see that okay now? If I translate it to a graph, it makes more sense, right? Huh? Because it's not halfway in between 55 and 105? Or, yeah, 155, excuse me. 55 and 155, the halfway point in between is 105, right? Because you have to add 50. Right? So this is like our amplitude. Everybody agree with that? Okay. Well, the amplitude can be positive or negative, right? That we haven't decided on. And in this case, actually, I already know that I'm going to make it negative. I'll explain why in just a minute. How I can tell anyways. So we have the information that we would normally get about K and A right away, using just the height and the diameter, right? Let's just make a little takeaway. So if we say the minimum is the height plus the radius, and the y max is the height plus 2 radius, then K is the average of those. And then A is just going to be, or well, the absolute value of A is just going to be the radius. Oh. This just simplified down to height plus radius. Yes, that's 2 radius, aka diameter. I don't know how it's going to be given to you in the problem. Sometimes it may give you a diameter, sometimes it may give you a radius. I'm going to write as 2 radius. Should we put diameter in parentheses after it? We can. Be super, like, we make this really busy. So that's what we've kind of come up with so far, right? That the A is going to relate to the radius, the K is going to be like the height plus the radius, or you could think about using the y min and y max formula. It's fine, right? Still going to be doing the same thing. So far, so good? Is this okay? Trying to present this both like intuitively and formulaically at the same time. So we're going to kind of talk through how we're coming up with the formula, right? So far, so good? All right. Now let's think about what this this piece is going to give us. What is that going to allow us to get? So if it does one spin in 102 minutes, yeah, so we start out at 0:55, and then like it says t in seconds, so that's why I'm doing 120. We're back down to that low point on the Ferris wheel, right? So that's exactly what it's going to give me. That one period is 120 seconds. And I know a period is the same as 2 pi times the absolute value c. So c is going to be 60 over pi or negative 60 over pi. But we're always going to choose our c to be positive. Well, it says it does 1 revolution in 2 minutes. Oh, sorry. Yeah, 120 comma 55. Of course. Yes, thank you. If you see me making mistakes, please correct me. You're doing the right thing. Yeah, of course I can. Sure. No problem. So, all we need now is to decide whether we want to use a sine or cosine function, figure out whether our a should be positive or negative, and then find our value for h. Everybody's cool with that plan? What piece of information am I going to use to do that? That the rider enters the Ferris wheel at its lowest position. So I'm going to use that this is the point that I'm going to be, needs to be a point on my function. If I'm at, what kind of point is 0, 55? It's a minimum. So should I use sine or cosine for that? Cosine.
So is K 55?
No, K was 105.
Oh, yeah. Oh, I meant H.
Nope. Oops. Mr. Kulik is already making mistakes, and now this OneNote is going ballistic on him. Just, can I scroll OneNote?
Why is it cosine?
Because I have an extrema that I'm trying to map onto, and it's going to be easier to do that with cosine because I can pick a point from the parent function that's an extrema whose x-coordinate is 0. So, because these guys are opposite, if I'm going from a max on my parent function to a min on my resultant function, that tells me the value for a is negative. So the a should be negative 50. There's a little negative sign in there. It didn't show up very much. And then, since the x-coordinate on my parent function is 0, that makes the x-coordinate on my resultant function h. So h is just 0, and I have everything I need to write y equals negative cosine of 1 over 60 over pi times x minus 0 plus 105. Did I read this wrong? Yeah, I did. Okay. So Mr. Kulik made a little boo-boo here. May I point something out to you? And it's a reading comprehension boo-boo, which is like the worst kind of boo-boo. So read that in green. Yeah. So my picture's like totally in the wrong spot. Mr. Kulik!
Just leave it out.
Yeah.
That's how you solve the problem.
Yes.
Just cross
Yes.
out.
So here's all that's going to change, right? What's the low point on mine going to be now?
0.
No.
5.
5. Why? Let's redraw the picture.
You get it?
So here's the center.
I did it. I was wondering if you did.
Diameter's 50. And the center is 55. Right? So what's this little piece got to be? 5. So this point is 0, 5. So that makes y min 5.
So is the equation above for the one that did or the one that you're doing?
So what I did before, I misread the problem because I was going too fast and being Mr. Kulicki, and I misread the problem, and I drew my picture incorrectly. For the picture that I drew above, everything is fine. The problem is that that picture above doesn't match the words in the problem. To match the words in the problem, I should have my picture here. And that's the issue. So where's my midline here? 55. What does that change in our answer? The only difference that would have made is to the value of k. So everything else was still fine. Olivia, you had a hand and then you retracted it. Did I answer your question?
Before that, like, for the first part, you messed up that k was 55.
Right, I did because I've done this problem a million times and I drew my picture wrong and I was like, I knew it should have been k, and then I was like, oh no, it can't be k. Look at the picture I drew, and I didn't go back and reread my problem to be like,
In the first part, k was 1.5.
with the picture I drew, which was the wrong picture,
Yeah.
the k was 105. For this problem, the picture I should have drawn to answer this problem, it should be 55 because I just drew the picture wrong. You know what I mean, Olivia?
Yeah.
Okay. Jacob. Certainly. Look. Mr. Kulik, now I'm so confused. Don't be confused. Let's do another, right? Should we try on another one? Gee whiz. I know. I'm frustrated at myself as well. It's okay that you're frustrated too. I deserve it. Okay? I don't know how many times I said I'm sorry. I didn't mean to do it. You ever make a mistake? Happened to me. You know? I'm trying, guys. I really am. I promise. Okay. Have I paused long enough to give everybody a chance to catch up, to make any fixes they wanted to make based on what I have done? Any notes to themselves of like, hey, this is, if it was 55 feet from the bottom versus 55 feet from the center, you know? Yeah, Mr. Kulik. The picture is important. I will do a better job of reading the next problem. All right. Let's do it again. So here it says, using the function from example A, we're going to take the correct answer. The answer I should have written. It says, find the height of the rider after he has been on the Ferris wheel for 73 seconds. How would I do that? Yeah. Yeah, again, Mr. Kulik was a bozo there and should have been using h of t and t, but yes, you're 100%. And just for the sake of making this easier, I'm going to write the simplified version, where instead of writing as 1 over 60 over pi, I'll just write it as pi over 60. And instead of the minus 0, I'll just drop the minus 0 part. So that I'm just plugging into my calculator. Before I plug that in, what should I check?
That you're in the right mode.
That I'm in the correct mode. What mode should my calculator be in? Radians. Oh, good. I'm all set to go. Oops.
Wait, why isn't it? Why is it radiant and not?
See the pi in there?
Oh.
If I had said the period equals 360 times the absolute value of c, then I could have used degree mode. But because I chose to write my c in radians, because that's what we do when we're graphing things, that's why I need to make sure my calculator is in radian mode. So if I do that, I get about 93.86 feet above the ground. Well, Mr. Kulik, that's a piece of cake. I love it. You're just plugging it in, man. Sophia.
Look at the sun.
The problem?
Oh,
Yeah, no, I get it. I get it, for sure. I read it, and then I started writing, and I had to scroll because I got, All right. Part B says, a woman's height is 45 feet off the ground. How long may she have been on the Ferris wheel? So what am I doing there? Where's the 45 go into? Great, that'll go in for my h of t. And now I just need to solve for t, right? What's the first thing I should do? To get that t by itself. Subtract 55. Great. Now what? Great. Divide by negative 50. Okay. Now what? Very good. We'll use inverse cosine. Because the inverse cosine is going to just cancel out regular cosine. And then my last step would be to or multiply by its reciprocal, 60 over pi. That's how I'm going to write it, but you're not incorrect. And keep in mind that I can't multiply that inside to the 1/5, right? Just type that into the calculator. I get about 26.15 seconds. Is that the only answer?
No,
No. Why not?
it could be 45 feet off the ground on the other side.
Mm-hmm. Or could be 45 feet off the ground on the second time around, or the third time around, or the fourth time around, right? Notice, though, that what did the question ask for? So is our answer okay? Yeah. Were there other answers that you could have gotten that would have been okay? Yeah. Would you have plausibly come up with those yet? Probably not. But I want to acknowledge that there are more answers. I think the next chapter we deal with solving using the inverse trig functions to find all these solutions. So that's coming up if you're curious, like, how would I even do that? Elena.
Are all of these problems going to have like some sort of like circle in them or something? Yeah.
Yeah. Or at least something that could be like thought of circularly. I think this next example is the trickiest because there's not an obvious circle going on. So, but it's like, I think a little bit easier to see the sinusoidal relationship. At 5:15 a.m., high tide comes in on Siesta Key in Florida, and the depth of the water is 18.3 feet. At 11:27 a.m., the depth of the water at low tide is 11.8 feet. Model the depth of the water using a sinusoidal function. Find the depth of water at 8 p.m. When will the first high tide occur on the following day? All right. So, you know what I hear when I read this question? I hear maximum at and then minimum at you guys agree? Thinking about it that way, right? It's just telling us a high point and a low point, and that's how tides work, right? They go out and they come in, and they go out and they come in, and they go out and they come in. What is that based on? Where the moon is. Yeah, the moon, the gravity from the moon is pulling the tides in and out. That's causing the tidal action. Everybody's cool with what we're doing here? Now, what's the problem so far with the way I've written these points? Yeah, the times are written with hours and minutes, right? Everybody agree with that? So we got to fix that. I'm going to write those as decimals in terms of hours. Feels the easiest to me. So if I take 5 hours and 20 or in 15 minutes is how many hours is that? 5.25. Everybody agree with that? 15 minutes is a quarter of an hour. How about 27? Yeah. So just like we've done before, we have this problem, right? Boy, this looks familiar. In fact, it's identical to what we have done prior, right? Now that we've translated everything into just real, into single unit, and recognize that all we really have here is a max and a min. So how do I find the midline? Well, y max plus y min divided by 2. So that's 1505. And then we can find the amplitude by doing y max minus y min divided by 2. When I do that, I get 3.25. So again, this is telling me the K. And this is telling me the possible values for A. Now, if I look at this, that would be one full period, right? How much of a period do we have? Half. So I can say half a period is equal to 11.45 minus 5.25, which is, what's that? That's 6.2. So one period then is 12.4. So 2 at pi times absolute value of C is equal to 12.24 or 12.4. So that tells me C is equal to then 6.2 over pi, or negative 6.2 over pi. We're always going to choose the positive option, though, for C. Everybody still doing so far so good? It's all right? Okay. Next up, we need to decide whether we want to use a sine or cosine function. Very good, I would agree, cosine, because we have extremas are the points that were given. And then we need to decide whether the A needs to be positive or negative and find the value for H. To do that, we need to pick a point. So you guys have already told me we're going to use cosine. Which point from our resultant function do we want to use? Just going to use the first one is fine with me. So 0, 1 was a maximum, as was the resultant point. So that tells me the A should be positive, and the H should be 5.25. So if we put this all together, I don't know, I'll call this another h of t function, I guess, since we're talking about heights of water. So there's our answer for A. Okay. For B, it asks to find the depth of the water at 8 p.m. So what are we going to be plugging that time into? T. What time is 8 p.m.? Nope. 20. Why?
24 hours a day.
Yeah, it's 12 hour. It's been 12 hours to noon and then 8 more hours, right? So the T is not the time, it's the elapsed time. It's not the time of day, it's like the elapsed time. So at 8 o'clock, it'll be 20 hours gone on. So go ahead and do that again. Worth reminding us that we should still be in radian mode, because when we found our period, we used 2 pi when we did that, right? So it should still be a radian problem. Guess I could have done 20 minus 5.25 in my head and saved myself a bunch of buttons, but oh well. So I get about 16.26 feet. Just as an aside, is that closer to high tide or low tide? Closer to high tide, right? It's past the midline, right? The midline's 1505. So it's above that. It's closer to the maximum than it is to the minimum. Everybody agree? Okay. Part C says that when will the first high tide occur the following day? When is that? So when is our first high tide? So we know high tide is at 5:15 or 5.25. We know the next high tide will occur not 24 hours, but one period, right? How long was one period? 12.4. So that's going to be 17.45. Note that that's less than 24. So we're not into the next day. Is everybody okay there? And then maybe we'll say the third high tide then. We'll change that to second. Is going to be 5.25 plus 2 periods, or 1745 plus 12.4, which would be 29.45. And that's okay. Everybody's okay with that? So what does that equate to? If I subtract, what time is that the next day? So we'll subtract 24, 5.45, so that's 5, and then how many minutes is 0.45 of a minute? It was 27. We did this already, but just to show you, I just do 0.45 times 60. And then since that number is less than 12, I know we're talking about AM. So it should, our next high tide the following day should be that. Oh my God, Mr. Kulik. Who sees my problem?
Did you?
I can't arithmetic today either,
Yeah.
right? This should be 65, which is a bummer because that makes that 65, and that makes that all different to 305, and that becomes 605 then. Or yeah, which is 603, I think. Ay caramba! It's the end of the day, guys. I don't know. You just made a mistake. It's not. I'm not having a good. It's definitely a case of the Mondays. Rita.
I like the one before, like the.
Part B?
Yeah, I like put it into my calculator, I got 39, and I'm in radians, like, you know, so I probably put that wrong.
Did you remember to do the flip?
Yeah, pi over.
Did you put a minus instead of a did you do like a negative sign instead of a minus symbol?
Maybe I could try.
That's something that's easy. That's an easy mistake to make. My next guess would be a parenthesis.
I put like the same or else I could.
Check the minus versus the negative. That's an easy mistake to not be able to catch. You know, definitely goober up your answer.
Still got 39. Quick.
Oh no. I'll take a look at it in a second. Deal?
Yeah.
Okay. Since this is like hyper specific. All right. We okay? This is the last thing I have to do for you guys. So I think 27 to 30 will be the last of the problem set. We don't have a worksheet from this section, so that's all we got. But what else does this mean? So we'll have the review day next time and then the test the following day. So what's that? Review day will be
Tuesday?
Oh, I'm in degree, yeah.
so let's see, what is so the 17th will be the review day, and then maybe the 19th will be the test day.
Oh, I'm hold on, I'm putting it wrong.
That's probably what we're looking at. That's a 4, by the way. That looked like a 9.
I typed something wrong, and then I changed it, and I got 16.
Let me type it in your computer.
Next week starts on the 8th.
Did you put this in?
All right.
There's no way that's better.
Oh.